Here's another tricky question in which people commit mistake. Here's a block of mass m, there is some external force being applied on the object and the object doesn't move. It is given that the object doesn't move. This surface is rough with a friction coefficient is equal to mu. We need to find out the force exerted by the surface on the block. Now what most people do is that they find out only the frictional force exerted by the surface on the block. Now surface exerts two kinds of forces on the block, that is normal and friction. So you have to take the resultant of normal and friction to find out the total force being exerted by the surface on the block. People miss out on either one of them and they get the wrong answer. So let us solve the question here. The normal force is equal to mg. The friction force is the static friction force. Fs is the total force, mind you. So small fs is the static friction force, which can have a range of 0 to mu s into n. Because this object is not moving under the experience of an external force, therefore we know that some static friction force is acting whose range is between 0 to mu s into n. So let us find out what mu s into n is. Mu s into n is mu into mg. So the value of friction force ranges from 0 to mu mg. So the total force acting on the object is normal in the upward direction and static friction force in this direction. So it is Fs in this direction. Now since these two forces are perpendicular, we can find out the resultant simply by root over n square plus Fs square. This is the resultant force, capital Fs, acting on the object by the surface. So when we find out this force, Fs is equal to root over m square g square. Let us find out Fs max. Fs max is equal to root over m square g square plus maximum value of Fs square, that is mu square m square g square. This is equal to mg root over 1 plus mu square. Now Fs minimum is equal to root over m square g square plus 0, that is equal to mg. So the range of Fs is mg root over 1 plus mu square and the minimum value is mg. So the option which matches our result is C. So the final answer for the range of force exerted by the surface on the block is this one.